observe in the previous class, so we discussed few things with respect to the C module. So to begin with, we started understanding about the C programming language. So what is the necessity of studying the C programming language, or how is it effective compared to all other programming languages we have studied. So then after after the introduction to the C programming language, so we started with understanding the applications of the C programming language. So if you look at the applications of the C programming language, we have got the C being used in kernels development, C being used in firmware, middleware, and driver development. Highly C is preferred in embedded systems software development, and C is used in file system management and many more fields. So C is referred to be the mother of all programming languages. Whenever you study the C programming language, it helps you improve the logical thinking, and it helps you learn any other programming language effectively. So that is why we study C, and C is the best suited programming language in order to make sure that you have an embedded system design. Whenever an embedded system is to be designed, so the C programming language is mostly chosen because in case of the C programming language, it utilizes very less time for its execution, also utilizes very less space for its storage. So apart from that, we saw how to write a basic C program. So whenever you are writing a basic C program, you start with the very first line, that is #include. Then after that, we are going to start with the main function. So inside the main function, we write all our statements to be executed. So either you can write int main or you can write void main. So the reason why we write int main is we want to thank our operating system for getting our program executed. So we follow int main and return 0. When you write void main, you are not thanking your operating system for executing the task. So otherwise, there is no other difference. Whichever you are comfortable can be utilized. Then we wrote some programs. We understood that programs are written according to our interest. And whenever a program is written, we are going to have it translated so that the machines can understand it. So in order to translate the program you have written to a machine understandable language, we make use of a compiler. So compiler acts as a translator. Then we study the types of data. We have integer, character, and real numbers. To store integer, we are going to make use of int as the data type. To store character, I will use char as the data type. To store real numbers, we will use float and double. So based on the compiler, you get certain bytes of memory allocated. Okay. Then after that, based on the value to be printed, we are going to make use of printf function to be printed, and to read the values from the user, we make use of the scanf function. So these were the things we studied yesterday. Then we started with the difference between float and double. So float gets only 4 bytes, double gets 8 bytes. Float will have single precision where the data is less accurate. Double will have double precision where the data will be more accurate. Then to read the data from the user, we make use of the scanf function. We specify the type of the data to be read and where the data should be stored. Then we have modifiers which are used to modify or change some of the properties of the variables. So size modifiers will change the size of the integer variable. If integer gets 4 bytes, you want long integer, you are going to, you want 8 bytes, you go for a long integer. You just want 2 bytes, you can go for a short integer. So we saw the minimum value to be stored, the maximum value which can be stored in these variables. Then sign modifier will tell whether you will be storing either a positive or a negative number, or you are going to store only a positive number. So if it is signed, all of these are signed, wherein you can store either a positive number or a negative number. So this is unsigned, where you will store only a positive number. Okay, so that is what we discussed in previous class. In today's class, we have to start with if and its family, the switch case and the loops. Okay, now to study, okay, let me quickly take you through the things here. So this shows how the data gets stored in the computer's memory. You can quickly refer. Now coming to the data types, under integral data types, we have character and integer. Okay, so character to store one character, integer to store any integer value. Then under float, we have float and double as the two data types. So float will get 4 bytes of memory and double will get 8 bytes of memory allocated. Okay. Then apart from that, size modifiers we studied. Short, long, long, long. Long, long is not supported by all of the compilers. If long gets 8 bytes and long, long also gets 8 bytes, it makes no difference. In some of the cases, long, long will have 16 bytes also. If your computer gives you 16 bytes for long, long, then you can utilize long, long. In my case, long, long size is 8 only, so it makes no difference between long and long, long. Okay, so that we call it as modifiers. And we have signed and unsigned, so that we call it as sign modifiers. Signed, where you can store either a positive value or it is a negative value. Unsigned, where you store only positive value. So these were the things we discussed in the previous class. Any doubts still here? You can ask your doubts. You can go to the questionnaire, type your doubts. Okay. So Sushant is asking, ma'am, in size.c file, you have used %d for age, which is float. Kindly check. No, let me show here. In size.c file, okay. So I am not printing the value of float or double. Okay. So whether it is character, I'm not printing what is stored inside character or height or age. I am checking how much is the size of CH, how much is the size of height, how much is the size of age. So size will always be one integer value. That is why I'm printing using %d format specifier. I'm not printing the value of height or age. I am printing the size of height or age. Size of height or age will be one integer value. So I'm using %d format specifier. Okay. Then okay. So then we have, is this internship only based on embedded software? Yes, our focus is to help you design an embedded software. We will have you given with an embedded system design. So you will design one embedded system by the end of this. Where can we get the videos? So all of these recorded sessions will be provided to you through a platform called LMS. So there is a learning stream. So there you are going to use it. Okay. Then what is single precision and double precision? So single precision means accuracy, less accurate. Okay. it is possible that the accuracy of your data might be lost in case of single precision, whereas in case of double precision, the data is double accurate. So it is not possible for you to lose the accuracy of the data. Okay, then so about LMS, you will get the link. So you will get the access to the LMS, only then you will be able to utilize it. Okay, wait for a few days, you will get the access. And attendance will be taken from the attendees list. We have a list of attendees. We will get a report of people attending the session for how much ever amount of time. So we get that detailed list. Through that list, we will consider the attendance. Okay. So then, ma'am, will we have access to these lectures even after the internship end? To some extent, yes, you will have. Do not worry about it. Okay, ma'am, do we need to study data structures in C language? For this internship, it is not necessary. Can you show the data type.c file? So this is the file wherein we tried reading the values to the variables and printing it. Okay, right. So coming back, how it's ensured that data will be stored in double and is lost in float. Data will be secured in double and data will not be lost in double and is lost in float. Sometimes, I'm saying it is not always. Okay. For example, you try storing some 36.09987, something like this. It is possible that your data might end up becoming 36.0998666, something like this. A little of the precision is lost when it is float. Okay, but in double it is very accurate. It is retained as it is. That is because the memory being utilized is more for your data to be stored. Which tool will use for all programming? So as of now, I'm using VS Code. Okay, you can use any online compilers to have your programs typed. Okay, can we use Python instead of C? You can use any programming language. In this internship, we will be studying about the C programming language. Okay. Now, to start with, today we are going to study about if and its family. Okay, so let us start if and its family. Now, what is this if condition is? Remember, when you have certain set of statements to be executed and it is based on a specific condition, then we are going to make use of an if condition. Okay, so let's say I have code A to be executed. Okay, assume I have code A to be executed when some condition is true. Okay, so when some condition is true, I have a code A to be executed. So that is in case of a if condition. So for example, let's say, assume you will be asked to print hello only if the entered number is 5. Okay, print hello only if number is 5. Only if number is 5. Okay, so you have to print hello only if the number is 5. That is when you are going to make use of an if condition. Okay. Mani Sai Raju is asking, is it mandatory to learn C and data types in embedded system? Yes, it is definitely necessary. Is it there any hands-on training for C programming during internship? Hands-on training in the sense you have to type these programs and practice by yourself. Okay. So is there any project in this internship? Which microcontroller will you provide? Will you prefer? Yes, you have one project to be done, and the microcontroller we are using is the PIC microcontroller. Okay. So now I'm trying to create one file here. Okay, sorry. File here, which is nothing but if and its family.c. Okay. Now, first thing here we are trying to do is we are programmed to practice if and its family. Okay. So that is what we are trying to do. First, I'm trying to include the header file as include stdio.h. Then in the main function, I'm going to declare one integer variable. Okay. So I will ask the user to enter one integer. Enter one integer. So based on this message, user will enter one integer which I am going to collect and store it inside a variable called num. So I am going to make use of scanf function. Scanf %d will end up reading one integer and I am going to store it inside address of num. Now, according to the question here, the question says you have to print hello only if the number is 5. So, I'm going to add one if condition. So, remember the syntax of if condition. I will use if, then I have to specify the condition. Some condition should be specified here. Only if it is true, I have to execute the statements, whatever is written inside this block. Otherwise, I will not execute it. So, I'll just come out of the program and continue the rest of the instructions. Okay. Now, tell me what should be the condition here to be returned when I should execute. Here, I should print hello. Printf hello. The question is to print hello only if the number is 5. So, what should be the condition here? Okay, so the condition I'm going to write here is number equal to 5. Okay, if the number is equal to 5, then I'm going to print this message, otherwise not. So that is why we make use of one if condition. Anytime you use an if condition, it is to check a specific condition. Here, when number is 5, I'm going to print that hello. Okay. So now observe, I'll save and I will execute. GCC and I'm compiling the program. So then I'm going to execute. Okay. So enter the number. I entered 10. Now 10 equal to 5 is false. So I did not get the message printed. So similarly, if I enter 5, then I'm going to say hello. Okay. So that is in case of a if condition. I add a keyword called if. Inside the parenthesis, I specify the condition number equal to 5. Condition is true. The statements written inside this block will be executed. Condition is false. These statements will not get executed and you continue as usual. Okay. So that is when I'm just copying this logic and putting it here. So this is to print only if the number is 5. Now let's say I want to check if the number is greater than 5 or less than 5. Check if the number is, check if the number is odd or even. Okay. So I have to check if the number is odd or even. Okay. Now, or I will say, okay, check if the number is odd or even. So I have two messages to print. Okay, two messages to print. One number is odd, the other is number is even. Okay, I should make use of one condition here. Condition is true, I print odd. Condition is false, I print even. Can you tell me what should be the condition? What should be the condition? I should check if the number is odd or even. Now, to identify whether a number is odd or even, obviously I have to make use of if-else block. If the condition is true, I will say odd, else I will say it is even. So I have to make use of if-else block. Now, what should be the condition here? Correct. I should check the remainder. Okay. Whenever you divide a number by 2, you get the remainder as 0, then it is even number. Remainder is 1, then it is an odd number. Okay. So, when we divide the number by 2, okay, if remainder is 1, okay, then number is odd. Number is odd. Else, if remainder is 0, then number is even. Okay. So remainder is 1, number is odd, remainder is 0, number is even. So we'll write it. To check the remainder, we have to make use of modulus. So modulus is an operator which gives you the remainder after dividing a number with the value you specify. Okay, so I'm going to write here. If the number mod by 2 is equal to 1, then the number is even. So printf, I'm going to say number is even. Okay, so number is even. Otherwise, I can say else. I don't have to check for another condition. Either it is odd or it is even. So here I am going to say number is even. So I will not waste my time in checking for another condition. If not odd, obviously it has to be even. So that is one if condition. So I am asking the user to enter one number. I am dividing the number by 2 and getting the remainder. If the remainder is 1, number is odd here. Okay. If the remainder is 1, number is odd. Otherwise, number is even. So let me execute this. I am compiling and executing. So I enter the number as 10, number is even. I execute again, I enter 5, number is odd. Okay, yes. So when number mod by 2 equal to 1, then number is odd, otherwise number is even. Good, I can see most of you are paying attention. So good. So when the remainder is 1, then the number is odd, remainder is 0, number is even. So that is to check. I'm just copying the logic here, putting it up here. Okay. So it's like this. Okay, that is nothing but your if-else block. Now let's say I want to check for 3 things. Okay. So next question. Check if the number is positive. For 0, the logic will not work. Okay, for 0, it will not work. Check if the number is positive or negative or 0. Okay. So I have to check if the number is positive, negative or 0. Now I have 3 different messages to print. One to say number is 0. Okay. So I want to check number is 0. If not 0, I want to check number is positive. Otherwise, I am going to say number is negative. I have 3 different decisions to make. Okay. So I'll have 3 different decisions to make. How to check if a number is 0? How to check if a number is 0? Correct. So I'm going to make use of a condition. If number is equal to 0, then the entered number I have entered is 0. Now, if the condition is true, okay. Okay, I'll say it is 0 and I step out. If it is not 0, I have to decide between positive or negative. Now, to say it is positive, I'm going to make use of another condition. Okay, to say it is positive, I'm going to check if number is greater than 0. Okay, if the number is greater than 0, true, you print it as positive. False, I don't have to check for another condition. I can directly say number is negative. If it is neither 0 nor positive, obviously it has to be negative. So I can directly jump and say it is negative. Okay, so I'll write it here. If number is equal to 0, so number is 0. Okay, else if your number is greater than 0, then I will say number is positive. Okay, otherwise in the else block we say number is negative. Printf number is negative. Okay, so I have it like this. So this is our main function. I'm asking enter one integer. I read the integer from the user. I'm checking if number is 0. If it is not 0, then number is greater than 0. I'm checking, then it will be a positive number. If both the conditions are false, it comes to the else block and say number is negative. Okay, so this is how we are going to check about the 3 different things. Okay, so let me execute this and show you the output. So I'm compiling here and executing. Okay, so I enter the number 10. You see it's a positive number. I enter the number -3. It's a negative number. I enter the number 15. It is positive number. I entered 0. Number is 0. Okay, so that is how you check whether the number is positive, negative or 0. Okay, so this is a simple if condition. Number equal to 2. What will be the output of this program? Okay, so number is initially 2 here. 2 less than 5 is true. So num1 less than 5 will be printed. Then as usual, number is %d prints the value of num1 which is 2. So number is 2 will also be printed. Next, this is if else block. What will be the output of this program? Okay, Abhinaya is asking, can we use else if as if else? No, you cannot. Okay, so in this case, num1 is initially 10. 10 less than 5 is false. You go to the else block. Num1 is greater than 5 should be printed. Okay, so here num1 is initially 10. 10 greater than 5 will be printed as a message. Then this is if else block. What will be the output of this program? Okay, so now number is 10. 10 less than 5 is false. 10 greater than 5 is true. So number is greater than 5 will be printed. Okay, so that is about if else block. So we have an if condition, we have an if else condition, we have if else condition. You can add any number of else if conditions whenever it is required. More the number of statements to be executed, you can utilize more the number of conditions also. Okay, so that is if and its family. So let me just copy the logic here. Okay, now this is for your third. Next we have a switch case. Now what is the switch cases? It is a substitute to the if else block. Okay, a quick substitute, I would say, a quick substitute to the if else block. Okay, so when you write an if else block, it ends up consuming more time for its execution. Okay, so when you write a if else block, let's say I want 4 messages to be printed. Okay, so one message I have to say number is 10. Then I want to say number is 20. Then I have to say number is 30. Then I have to say number is 40. Then I have to say neither 10 nor 20 nor 30 nor 40. Okay, or I can say none. I want to say it like this. Can you tell me how to write it with the help of a if else block? So when I have to write it with an if else block, first I have to write if number is equal to 10, then I'm going to say number is 10. Okay, printf number is 10. Okay, so number is 10 like this. So otherwise, I'm going to like just copy paste. Else, if the number is equal to 20, then I will say number is 20. Okay. Then maybe one more else if number is equal to 30. Okay. So we say number is 30. Then one more else if we are going to add, if number is equal to 40, then number is 40. If it is not any of this, I will say that in the else block, it is none. Okay, it's like this. Generally, this is how we are going to make use of the statements. Now, what happens is, to say number is 20, I have to first check number is 10. Only if it is not 10, it comes here and prints number is 20. Okay. Then, for example, to say number is 40, I first have to check if it is 10. Not 10, check if it is 20. Not 20, check if it is 30. Not 30, then we go here and say number is 40. Similarly, longer the if else block, larger is the time being consumed. Okay. So for that reason, we have to replace it with a switch case. Now, how to replace it with a switch cases? We can make use of a switch based on the value of number. Okay. Now, case 10. Okay. We have case 10. So, if the entered number is 10, I will say number is 10. Okay. So, I am going to say here number is 10. And once I step out of this, I don't want to continue. Once I realize that number is 10, I don't want to continue. I want to step out. So I'm going to make use of the break statement. So I can have any number of cases like this. Okay. Let's say. Then we have to print for 20, 30, 40, none. So case 20 here, we will say number is 20. Okay. Then case 30 here, we will say number is 30. Then case 40 here, we will say number is 40. Okay. So we will say number is 40. And the last case, the else case, we make use of default. So we have something called as default. So here I am going to say none. Okay, none like this. And to the very last case, break is not necessary. So we write it like this. So that is an alternative to the if else block. Now if the user enter number is 20, it directly comes here and say number is 20. If user enter number is 40, it directly comes here and say number is 40. It will not check one after the other. The mechanism is built in such a way that it directly comes to the required case and the statements will be executed. Then if the number you have entered is, let's say, 50, it directly jumps to the default case and says none. Okay, so that is about the switch case. So this is how the statements are executed. Okay, let me add this here. I'm creating a file switch.c. So first I will read the number from the user. So program to practice the switch case. Okay, so we are adding one default case. Okay, so this is one switch case. Now, Harshavardhan Kumar is asking, ma'am, will the project assigned during this internship be based on latest industry requirements? So the project which will be assigned in this internship will be based on the embedded program what you are going to study here. You will be given with a microcontroller. We will teach you how to interface a microcontroller, and based on that we will give you one specific project. So it is a hands-on experience of how to work with a microcontroller. Okay. Then, ma'am, in switch case only integer values we have to use. Correct, Samarth? So one drawback of switch cases, you can work only with integers. Okay. So I can only work with integers when it comes to the switch case. Your number should be integer. Your case values should also be integer. Okay, then Meet Trivedi is asking, have you wrote the case numbers? The case numbers I took based on the value I'm expecting for number. Okay, for number I'm expecting the values either like 10, 20, 30, 40. I'm expecting that. So based on that, the case labels are written. Okay, if none of these are entered, I will get the default case executed. Okay, then Shravani is asking, if we write case 1, printf number is 10, we give number is equal to 10. Okay, you write case 1 here. Okay, then you enter the number as 10. It will not match to any of these case. It will go to the default case. Okay, so I'll compile here gcc switch.c and execute it. So I enter the integer as 10. You can say number is 10. I enter it as 25. It says none. Okay, I have not added a backslash n here everywhere. So that is why you are not seeing a new line. So backslash n everywhere here. It should be added. Okay, so like this we are going to enter, and whatever the entered number is, based on that the message gets printed. Okay, enter the integer 45, so none will be printed as the output. Okay, so Buddha Praneeth is asking, ma'am, in case state, sorry, Buddha Praneeth, madam, in project have to be done in groups or individual? It is up to you. Either if you want, you can use group, or you can do it in person also. Can we use float or character data type also in switch case? No. For switch case, you can use only integer, maximum character. Float, highly impossible. Okay, we have to buy microcontroller. No, you don't have to buy the microcontroller. So who is asking? Gopi Shetty is asking, no, please don't buy any microcontroller, not necessary. We will teach you what to be done. Please have patience. Okay, so that is about the switch case. So one simple example of switch case you can see here. Now assume the entered value is 25. What will be the output? So here the entered number is 25. It will not match to any of the cases. It will go to the default case and say try again. Okay. Then Sushant is asking, ma'am, while checking the else if condition, if during checking the first statement is correct, will the code stop there or it will check for the other else if conditions? So good question, Sushant. When the first condition is checked and it is true, it will not waste its time checking for the rest of the conditions. So for example, this condition is true, it will execute the statements and immediately step out of the entire if else block. So it will not waste its time checking the rest of the conditions. Only if it is false, checks the second condition. By chance second condition is true, you step out. You will not waste your time in checking for the rest of the conditions. Okay, Buddha Pranit is asking, will you create any groups for us? Not me. Once the microcontroller module starts, the group will be created. Okay, next. What is compile time error, runtime error? Okay. So compile time error is something you will see while the program is being compiled. We studied here. Whenever we write a program, we compile, we translate it so that your computer understands. While the program is being translated, you make any syntactical mistakes. Okay, that is compile time error. Any syntactical mistakes you make, you miss writing the semicolon, you miss declaring the variable, you miss closing the double quotes, an error. Okay, but in case of your runtime error, it is your logical mistakes. So any logical mistakes you have made, then that leads to runtime error. Okay, for example, you are trying to divide the number by 0, so you are trying to okay, but in case of your runtime error, it is your logical mistakes. So any logical mistakes you have made, then that leads to runtime error. Okay, for example, you are trying to divide the number by 0, so you are trying to access some random address, so that is all your logical mistakes. So logical mistakes will end up giving you a runtime error. Okay, as you can see, we have thousands of participants. Focusing on each one of your questions is quite time consuming. So whichever appears in the front, I'm just taking it up. Okay. Then, okay. So one more question of Sushan. If I have to check for other conditions, I mean all the conditions I have to check. It is impossible, Sushan. If you want to check for all of the conditions, then it has to go to else block only. Only if all the conditions are false, you go to the else block. So what if the first condition is true, you want to check for the second condition also, then it is impossible. If that is the case, you have to write separate if conditions. So one if you have to write, you want to check for this condition also, write it as a separate if. You want to check this conditions also, write a separate if. You cannot make use of if else. Okay. Ma'am, in which case if we give like case 10, break case 10, number is 20, execute. It is an error. It is a compile time error. You write case 10 and case 10 here, you get an error. Because case 10 is already there, taking another case 10 is an error. It tells you are trying to create a duplicate. Okay, duplicates cannot be created. So if you observe here, it's an error. This is compile time error. It is the mistake which your compiler identified. So it says duplicate of case. It called case 10 in line number 12. It is already there in line number 10. Okay, so that is about your switch case. So let us take a break of 2 minutes and we'll continue. Okay, so we will proceed. Recording lecture, where do we get? So any logical mistakes you have made, then that leads to runtime error. Okay, for example, you are trying to divide the number by 0. So you are trying to access some random address. So that is all your logical mistakes. So logical mistakes will end up giving you a runtime error. Okay. to that platform. You will be given with login details to join LMS in 2 to 3 days. Okay, so then Anthony is asking, does indentation matter in C or we get error as in Python? So indentation is not followed in C. It's a free formatted programming language. So because of that, you will not get any errors if you do not follow any indentation. Okay, so LMS is a platform. So it's a platform or a link. Okay. So then okay, ma'am, kindly share an example of if condition in order to check all the statements even if the first condition is true. So if the first condition is true, you want to check for the second condition also. You write it like this. Just a minute. So the same if I take okay, not else if. So I write if everywhere. Okay, it is waste of time. Okay, so now if you enter 10, it checks number equal to 10, true. Again you are checking 10 equal to 20, false, waste of time. 10 equal to 30, false, waste of time. 10 equal to 40, false, waste of time. Okay, so that is what you will see. So it is not necessary. This is wrong. Okay. Now, whenever we have to execute a statement for more than once, we are going to make use of loops to execute the same statement for more than once. Okay, we use loops. So loops we call it as multi-iterational conditional constructs. Okay, loops are technically referred as multi-iterational conditional constructs. Loop will help execute the statements of yours for multiple times. Okay. Now whenever you are writing a loop, we have three types of loops. One is a while loop. Okay, then we have a do while loop, and we have a for loop. Okay, now what happens in case of a while loop? You write a syntax while some condition. Okay, and you write all the statements here. Okay, statements. So look at the way in which the while loop is executed. So in case of while loop, first it comes and checks for the condition. Condition is true, the statements will be executed. And after the statements are executed, you will take your control back to checking the condition. Again you check for the condition, true, statements will be executed. Again you check for the condition, true, statements will be executed. When the condition is false, you will come out. Okay. When the condition is false, you will come out and execute the rest of the statements. This is when condition is false. Okay. Now, while is also called as entry controlled loop. Okay. This we call it as entry controlled loop because as long as the condition is true, you don't enter into the loop here. Okay. So we call it as entry controlled loop. Now how to write a do while is? You write the statements here to be executed and here you will write the while condition. While some condition. Okay. Terminated by a semicolon. Now what happens is, once in case of do while loop, you come here, you execute the statements. Then again the condition will be checked. After checking the condition, if the condition is true, you will go back and execute the statements for another time. Okay, like this. See, in case of while loop, first you come and check for the condition. So condition is true, the statements will be executed. Again you go back, check for the condition. It is true, statements will be executed. Once the condition is false, you will come out of the loop. In case of do while loop also, one difference is, first you enter and execute the statements. Then you check for a condition. Condition is true, you go back and execute the statements again. Again condition is checked. True, you go back and execute the statements. Once the condition is false, you step out and execute the rest of the statements. That is when condition is false. Okay, so that is for a for loop. Then coming for a do while, that is for a do while loop. Coming to the for loop, we write it like this. For, we have initialization, condition, post evaluation expression. Okay, then you will have your statements executed. You will get your statements executed. Now first, you will start with initialization. Okay, you are going to check if the first thing you are going to do is step number 1 is initialization. This is step number 1. The second step is you will check for the condition. Step number 2. Condition is true, you will execute the statements. That is step number 3. Okay, condition is true, statements are executed. So that is step number 3. Then after the statements are executed, you will go to post evaluation expression, which is step number 4. Okay, step number 4. Then you will again come back and check for the condition, which is step number 5. Okay, condition is true, again the statements are executed. You go to post evaluation expression. Then condition is true, again statements are executed, you go to post evaluation expression. When the condition becomes false, you will step out of the for loop and execute the rest of the statements. Okay, so that is your for loop. Condition is false, you will execute the rest. You step out of the loop and execute the rest of the statements. A do while loop is called as exit controlled loop. Okay, it's a exit controlled loop. So you will enter the loop without any condition, but To come out of the loop, you want the condition to be false. So we call it as an exit control loop. So this is the example of a while loop, while, condition, the statements. So look at the flow chart here. Condition is true, the code gets executed. Again you will go back and check if the condition is true. Again true, you execute the code. You will go back, check for the condition. Again true, this code will be executed. Then again you will go back, check for the condition. Whenever condition is false, you will come out of the while loop. Can you look at this example and tell me what will be the output? I++ will increase the value of variable I by 1. Okay, right. So now in this case, it will print looped for 0 times to looped for 9 times. Okay. Now what happens in this case is, so first and the foremost thing, I have an integer variable called I with the value 0. Okay. I'm going to check if 0 is less than 10. Okay. 0 less than 10 is true. So I will get looped for 0 times printed. I++ will increase it to 1. I again come back. 1 less than 10 is true. So I will print looped for 1 times. 1++ will make it 2. Then I check for 2 less than 10. Again condition true. So 2 will be printed. So after 2 is printed, I++ becomes 3. Like that it keeps happening. Once I becomes 9, 9 less than 10 is true. Here also it prints 9. Then I++ makes it 10. 10 less than 10 is false. Once it is false, you step out of the while loop. So you get 0 to 9 printed. So this is do while loop. Do, the statements will be executed. Then while, condition is checked. So first code is executed. Then you check for the condition. Condition is true. You get the code executed for an other time. Again, you check for the condition. Condition is true. You go and check for the condition one more time. I mean code executed one more time. Again, condition is true. Code is executed for another time. So once the condition is false, so I will step out of the while loop. Can you tell me what will be the output of a do while loop? What will be the output here? So it's the same output. Initially the value of I is 0. So I enter the do while loop. So looped for 0 times will be printed. I++ will change it to 1. I check for the condition. So 1 less than 10 is true. You again come back. Looped for 1 times will be printed. Then I++ makes it 2. 2 less than 10 is true. You come back. Looped for 2 times will be printed. Then it keeps happening. When it becomes 9, 9 less than 10 is true. You get back and print the value 9. Then when I makes it 10, 10 less than 10 is false. You step out and execute return 0. So 0 to 9 will be printed here. Then we have a for loop. In for loop, we have initialization, condition, post evaluation expression. So first initialization will be done, then condition will be checked, then the code will be executed. After executing the code, it goes to post evaluation expression, that is I++. Then it again comes back to the condition. Condition is true, code is executed. Again post evaluation expression. Again goes for the condition, true, code is executed, post evaluation expression. It keeps happening. Okay. Once the code is false, you step out. Now what will be the output of this program? So here also the same 0 to 9 will be printed. First 0, 0 less than 10 is true, loop 0 times will be printed. I++ will take the value 1. So 1 less than 10 is true, 1 will be printed. I++ takes the value 2. So 2 less than 10 is true, 2 will be printed. Like that it goes till 9. Okay. Then once I value takes 10, 10 less than 10 is false. You step out and execute return 0. Okay. So that is nothing but your for loop. Okay. The next we have is continue and break. Now what is the difference between break and continue is? So continue should always be used inside a loop. Okay. Continue should always be used inside a loop, whereas break should be used either inside loop or switch case. Okay. So continue should always be used inside a loop, whereas break can be used either inside a loop or inside a switch case. Now what happens when continue is used is, we call it as jumping statement. Both continue and break, we call it as jumping statements. Okay. So both of these we call it as jumping statements. Now what it does is, whenever you get your continue executed, it skips whatever is written after it and continue to go to the next operation. Okay. It skips whatever is written after it and jump to the next operation. Whereas in case of break, so whenever break is used, it steps out of the loop. Okay. When break is used, it steps out of the loop. So that is the difference between break and continue. So whenever your continue is executed, it jumps to the next statement, whereas when break is executed, it steps out of the loop. Okay. Look at this simple example here. I'm using continue. Okay. What will be the output of this program? Okay, so here what happens is, as I said, it jumps. Okay, whenever continue is executed, it moves to the next step, ignoring all the things written after it. Now observe, the value of I is initially 0. 0 less than 10 is condition true. Okay, so you enter 0 equal to 5 is false. So this printf prints the value 0. Then it comes here, I plus plus makes it 1. So 1 less than 10 is true. Then 1 equal to 5 is false. So it comes here, prints the value of I, which is 1. I plus plus will be 2. So it is checking for 2 less than 10. 2 less than 10 is true. You enter 2 equal to 5 is false. So it prints the value of I, which is 2. Then 3 will be printed, 4 will be printed. Once it takes 5, 5 less than 10 is true, but 5 equal to 5 is also true. Once continue gets executed, it directly moves to the next step. One step will be skipped and moves to the next step. I plus plus makes it 6. 6 less than 10 is true, 6 will be printed. Because 6 equal to 5 is false, so 6 will be printed. Then 7 will be printed, 8 will be printed, 9 will be printed. So once it becomes 10, 10 less than 10 is false, you step out and you will execute return 0. You get all the values printed from 0 to 9 except 5 here. So when I became 5, you got continue executed and you just jump. Okay, so that is your continue statement. Similarly, break. Whenever break is used, you come out of the loop. Okay, the moment break is executed anytime, you come out of the loop. So look at this and tell me what will be the output. When break is executed, you have to come out of the loop. So now what happens is, the value of I initially is 0. So you will start from 0. Okay. So 0 less than 10 is condition true. Then 0 equal to 5 is condition false. So 0 will be printed. Okay. Then you go for 1. So 1 equal to, 1 less than 10 is true. So then you are checking for 1 equal to 5. False. Again 1 will be printed. Okay. Similarly 2 will be printed. 3 will be printed. 4 will be printed. Once I takes the value 5, 5 equal to 5 is condition false. 5 equal to 5 is condition true. The moment condition is true, break statement gets executed and you are going to step out of the break. Okay, you will come out of the loop and you will execute return 0. Program stops there. So the usage of break is when you want to step out of the loop abruptly. So somewhere in the middle, for some reason you want to come out of the loop, you are going to make use of the break statement. Okay. So whenever break gets executed, it comes out of the loop. Okay. So that is the example of break here. Any doubts still here? Okay. Sorry, I was facing some network issue due to rain. Okay. So that is about the if and its family. Switch case, loops. Okay. Now we have to start with operators. So let us understand some of the operators. Okay. The very first operator we have got to study is nothing but arithmetic operator. Okay. So we are studying about operators here. Operators. So we have many operators like arithmetic operators, we have logical operator, we have relational operator. Okay, we have relational operator, then we also have a bitwise operator. Okay, these are some of the operators we have in C. Now operators are nothing but they're the statements. Okay, so operators are nothing but they are the symbol which instructs the compiler as what to perform. Okay, so the instruction given to the system as in what to perform, we call it as operators. So in C we have multiple operators. So operators are the symbols that instruct the compiler to perform a specific operation. So operators will perform the operation on the input you provide, also give us the result. Okay, it performs the operation and gives us the result. For example, this is one arithmetic operator. Multiplication, division, modulus, addition, subtraction. Okay. Now, whenever you want to solve any expression with the help of these arithmetic operators, this is the order you have to follow. Okay. First you have to solve multiplication, then you have to solve division, then modulus, then addition, then subtraction. So we do not follow BODMAS rule. Okay, it is not the BODMAS rule we follow to solve any expression. So the computers will follow this order of solving the expression. So first we will solve the multiplication operator, then we can solve the division operator, then the modulus, then the arithmetic addition subtraction. Multiplication will multiply two numbers, division will divide two numbers, give you a quotient. Okay, remember division gives you a quotient, whereas modulus gives you a remainder. So division gives you the quotient and modulus gives you the remainder. Addition is plus, subtraction is minus. Okay, so that is how you are going to solve the expression. Now remember pre and post increment. Okay, so we have something called as increment operator, and we also have decrement operator. So increment operator is to increase the value by 1. Increases the value by 1. So whereas decrement operator decreases the value of the variable by 1. Decreases by 1. Okay. Now we have, see whether it is increment or decrement, remember it is increment will have the value increased by 1, decrement will have value decreased by 1. Now we have pre and post in that. Pre and post. Now the difference between pre and post is both of them will increase the value by 1. In pre-increment, the change reflects immediately. Okay, change reflects immediately. Okay, whereas in case of post, the change reflects for the next time. Change reflects for the next time. Okay, for example, there is integer variable called num. I do plus num. This is pre-increment. Okay, using plus before the variable, we call it as pre-increment. So in pre-increment, value changes immediately. Okay, now let's say I have one integer variable, num is 5. Okay, plus of num changes the value of num to 6 immediately. Now if it is assigned to y, okay, int y, so I write it like this, y is equal to plus num. Now what is the value of y? What will be the value of y? So after we have made the change, okay, first num changes to 6. Okay, first num changes to 6. Then y gets 6. Okay, first num changes to 6, then y also gets a 6. So that is pre-increment. The change will reflect immediately. I change the value of num to 6 immediately, and because of that you get the value assigned as 6. Okay, whereas in case of post increment, the change reflects for the next time you access. Okay, so for example, I have int num is equal to 10. Okay, then I have int y. I do y is equal to num plus. Okay, here first num gets plus. Okay, but changes to 6 next time, not here only. Okay, it changes to 6 for the next time you access. Okay, y gets 5 only. Y gets 5. Okay, num will be 6 after that statement. Okay, so please remember this. In case of pre-increment, the change reflects immediately. Okay, number is 5. I have my integer variable called y. So I am doing y is equal to plus num. First the num changes to 6, then y gets that value 6. Whereas in case of post, the change should reflect for the next time you access. So y will get the value 5 only. It remains 5. Sorry, not 5. This is 11. Okay, y gets 10. So first num gets plus but changes to 11 for the next time. Y gets 10. Num will get 11 after that statement. Num will get 11 after that statement. Sorry, I thought it is 5 only. So num is 5. Post increment, the change should happen for the next time. So first plus is only getting executed, but it changes to 11 for the next time. So y gets 10 and num changes to 11 for the next statement. So that is the difference between pre and post. Pre changes immediately, post changes for the next time. Okay. If you have understood it, what will be the output of the statement? What do you get as an output here? So here my value of num1, it is post increment. Okay, so let me write it here. This is one statement. Okay, this is an other statement. So num1 plus plus, the value of num1 changes to 1 for the next time. Here it remains 0 only, so 0 will be there. Plus of num2, num2 is 0, it changes to 1 immediately, so it takes 1. 0 plus 1, I'm expected to get 1. Okay, so I'm expected to get 1, but using plus plus in printf leads to undefined behavior. So whenever you use plus plus inside printf, you cannot expect the proper result. Okay, the result is variable. You cannot expect the proper result. Pre-post increment. Okay, see, our expected answer is 1, but we might end up getting something else. So gcc pre-post increment dot c, I'm executing. So sum is 1. It is not guaranteed that I will get 1 itself. Sometimes post increment leads to undefined behavior also. Okay, using post increment in printf sometimes leads to undefined behavior. But anyways, here the expected answer is 1. We get a 1.